Can anybody tell me what an absolute value is? Maddie?
It's like the positive form of any number.
Good, a positive form of any number. That's a good way to explain it. Anybody else? It's always positive. It is a distance from 0. It's the distance a number is from 0. And that's why it's always positive, because if you're talking about distance, then you can't have negative distance. So your definition right there, the absolute value of a real number is the distance from 0 on the number line. So that example is talking about the number 4. So if this is our number line, it's saying that the absolute value of 4, with these two vertical lines, the absolute value of 4 is 4, because the distance from 0 to 4 is 4. Well, the absolute value of negative 4 is also 4, because the distance from 0 to negative 4 is 4 units. It's always positive. Let's think about a situation where this absolute value would come into play. Say I am an elevator repairman. Okay, and here's my elevator. And I have a little man riding in my elevator. And because this elevator needs repaired, I want to tally how many floors the elevator travels within an hour. So my elevator went up 2 floors. Okay, so there's my tally of 2. Then my elevator went up another 2 floors. So that's 2 more floors. Well, then my elevator went down a floor, and now it ended up right here. So it went down a floor. Does it matter that it went in a negative direction? No. That's still a floor. I would still count that as a tally. Even though the direction is negative, I'm still counting the number as a distance. So I'm still counting it as a floor, so I would need to make it a positive value. And that's a way that we can use absolute values. Now, because we have absolute values and we have the opposites having the same absolute value, when we solve for absolute values, we can have 2 solutions. When you're solving an absolute value, such as the absolute value of 2x minus 1 equals 5. First, you have 2x minus 1 equals 5. And then you want to set your absolute value equal to the opposite. So 2x minus 1 equals negative 5. Why? Why are we going to do this? Because let's think about this. Don't even worry about the 2x minus 1. We don't know what this is. Say we just had a blank absolute value and I knew that it equaled 5, like it says right here. What could go in there? Corey? The absolute value of 3 equals 5? 5. Blank absolute value equals 5. What could go in there, Aaron? Negative 5. 2 numbers, 5 and negative 5, give you the same answer. That is why we have to set up 2 equations. One equal to 5 and one its opposite. Because 5 and its opposite have the exact same absolute value. So then once you're able to set up your 2 equations, you just solve. One x value is 3. And an x value is negative 2. So if you would fill back in 3 or negative 2, if you would substitute them in, you would get a true statement. Let's try the got it question number 1. What's the solution of the absolute value of 3x plus 2 equal to 4? So one equation is going to just stay the exact same, 3x plus 2 equals 4. And then for my other equation, I'm going to set that equal to what? 3x plus 2 equals? Good. 1 stays the same, 1 is equal to the opposite. And then I solve. X is 2/3. And X is -2. Now it says to graph this solution, all you have to do when you're graphing a single number is put a point on that number. With our inequalities, we were starting on a number and then shading with an arrow. But for just a number, all you have to do is put a point on that number. So when you have absolute values, you set up two equations. One that's just normal, and then one that's set equal to the opposite. Other equations, absolute value equations can be done in multiple steps. For example, here, what we need to do is we need to get the absolute value by itself before we set up our two equations. So think of that absolute value, that x plus 2, think of that as the variable that you need to get by itself. What should I do right off the bat to get that absolute value by itself? Lenny?
Put the negative, or write the same thing over again, but then put the -8. Or distribute.
We don't want to rewrite it yet with a -8 because we want to get the absolute value by itself first.
Then distribute.
Distributing would make it more complicated. We're trying to get the absolute value by itself. And those aren't parentheses, that's absolute value. That's okay. That's okay. I need some inverse operations here. Kyra.
Would you divide?
Yes, but not yet. You will divide by 3, but we have to do something else first. What is it? I have to do another step. Ooh, what, Lenny?
Do you have one?
Yes, you do.
I guess.
Remember, we're trying to isolate the absolute value, trying to get it by itself. Now we're going to divide by 3. And I get the absolute value of x plus 2 equals 3. Now I can set up my two different equations. X plus 2 equals 3. And x plus 2 equals -3. So x is 1, and x is -5. Graph those by putting a point on both of the values, 1 and -5. For the got it question, think about getting the absolute value by itself first. It's kind of the same sequence that we did in the problem before this. What should I do as my first step? Brennan.
Subtract 3.
Yep, very good. And then Rachel? Good. The absolute value of x plus 9 equals 2. Once the absolute value is by itself, that's when you want to split it into two equations. X plus 9 equals 2. And what's the other equation? Good, Rachel. Very good. Solve. -7 and -11 are your answers. Kaylee.
Can I get the math?
Yeah. So let's think about if I gave you a problem and I said, we are trying to find the distance we traveled from point A to point B. And here are two answers. X equals, the distance equals 4 and the distance equals -4. Which is my answer? Kyra? Right, it's not going to be negative. A distance can't be negative. And sometimes that'll happen when you're solving. You get two answers and you say, hey, this one doesn't make any sense. I can't have a negative distance. What that's called is an extraneous solution or an extraneous root. So what an extraneous root or an extraneous solution is, it is a solution that's derived from the original I'm just going to abbreviate equation for you, but does not make the original equation true. So you get it from the original, but then when you plug it back into the original, it doesn't make it true. In your homework, whenever it wants you to go back in and check for these, it will say, check for extraneous solutions. So you have an absolute value here. The absolute value of 3x plus 2 equals 4x plus 5. So one of my equations is going to look like that. Now remember, for your next equation, you want to take 3x plus 2 and set it equal to the opposite of the right-hand side. So you want the opposite of this whole right-hand side. So if you take the opposite of the right-hand side, you have 3x plus 2 equals -4x minus 5. Now, if you don't want to do this step right here with the parentheses, that's okay. You can jump right to just saying -4x minus 5. You can switch both of your signs. I just want to illustrate that the reason we're switching our signs is because we're multiplying that whole side, that whole right side, by a -1 just to get the opposite. So now it's time to solve. So on one of the sides, I get that x is -3. And on the other side, I get that x is -1. Now, what you need to do to check for extraneous roots is take those answers, -3 and -1, and put them back into the original. So I'm going to use my original to check for extraneous roots. The absolute value of 3 times -3 plus 2 equals 4 times -3 plus 5. The absolute value of -9 plus 2 equals -12 plus 5. And so the absolute value of -7 equals -7. What's the absolute value of -7?
7.
Does 7 equal -7?
Yes. No.
No! Absolutely not. And since that's false, it doesn't work. It does not make the original true. So x equals -3 is an extraneous answer. So it's not actually an answer that we can use. If you usually circle the answers that you can use, you may not want to circle it because really that's saying, hey, we got x equals -3, but we can't use it because it doesn't make it true. And then we need to go ahead and do the same thing and plug in -1. So we have the absolute value of 3 times -1 plus 2 equals 4 times -1 plus 5. So that's the absolute value of -3 plus 2 equals -4 plus 5. The absolute value of -1 equals 1. The absolute value of any number is positive, so we have 1 equals 1. Woohoo! That's true. So we know that x equals -1 is our solution. X equals -3 is our extraneous solution. It doesn't work. X equals -1 is our good solution. It works. It's true. Ta-da. Do you guys have any questions on the extraneous solution part? Okay, an extraneous solution makes my original equation what?
False.
False. Very good. This one's, and then that's all we're going to be doing for today. So we have 5x minus 2 equals 7x plus 14. And then who can tell me what we should do for the second equation? Who can tell me what that second equation is? Brennan.
5x minus 2 equals -7x minus 14.
Very good. He changed both the signs on the right-hand side because we want the opposite of the right-hand side. Now we just need to solve. Now, remember that if you guys decided to move maybe the 2 first, that's okay. You can move the 2 first, you could move the 14, you could move the 5x, you can move the 7x. It doesn't matter. you're still going to end up with x is negative 8 as long as you follow all your rules of solving. Yeah, Corey?
Show me what I did wrong.
Sure. You didn't do anything wrong. We solved this equation. This is the next one.
Oh wait, which one did we solve?
We solved this one.
Oh.
Just the regular one. You solved the one that was set equal to the opposite.
Oh, okay.
So this is good. It's just the next one that we're going to do.
Alright.
And then for the right-hand side, go ahead and solve. I tend to always, if possible, make my x value positive. You guys can do it as you like. So you get x is negative 1. So we've got two answers to try, negative 8, negative 1. Check for extraneous solutions. Go back to your original and put it in. 5 times negative 8 minus 2, that's what we're taking the absolute value of, equals 7 times negative 8 plus 14. So the absolute value of negative 40 minus 2 equals negative 56 plus 14.
Oh,
Yes?
that's extraneous. Yes.
Yeah, why?
Because 30 does not equal negative 32. I think that's what it is.
42?
42, yeah.
42? Right, because what's going to happen here is we're going to have negative 42 equal, the absolute value of negative 42 equals negative 42. That would be okay, except for that absolute value. That absolute value means, hey, what's the distance of negative 42 to 0? It's positive. And positive 42 does not equal a negative 42. So that's how we know that this is extraneous. So x equals negative 8? Sure, it's our solution until we plug it in, and then we know, hey, it doesn't work, it can't be an answer. Let's check and make sure negative 1 works. So we would have the absolute value of 5 times negative 1 minus 2 equals 7 times negative 1 plus 14. Negative 5 minus 2 equals negative 7 plus 14.
Can they both be extraneous?
They could be. They could be. Jackie? Oh, that's a very, very good question. Why is it plus 14? Because you want to go to the original equation. That's a very good question. Yep, make sure you're using the original. And so then we have the absolute value of negative 7 equals 7. 7 equals 7. We're in good shape. X equals negative 1 is our solution. You do have homework. Do you have any questions before I give you your homework? Was that a question, Akram? No? Okay. Like Jackie said, make sure you guys are aware when you're checking for extraneous solutions, you go back to the very first original equation to plug it in. Your homework is on page 46. 10 to 18 even. And then 19 to 24.